Hello students, today we are going to deal with design of staircase. So today we will see all the guidelines given by IS code and also detailing of staircase. Now staircase is the means of vertical circulation and is very important for any structure. Well, today's session will see two types of designs. One is functional design and second one is structural design. Now, in the functional design, you have to remember some of the guidelines. So, how much shall be the width of a stair? So, for residential structures, it is generally 1 meter. For public buildings, it may vary between 1.5 to 2 meter. Rise, that means the vertical height of each step. Maximum rise for residential building shall be 190 mm. Normally the range is 150 to 175, but we can extend it up to 190 mm. And for public buildings it is 150 mm. Trade, that's the horizontal width of each step. Okay, that is called as trade. Now, minimum width of trade for residential building shall be 250 mm and for public buildings it must be 300 mm. Length of flight. So, length of flight is defined in terms of number of steps. So, the number of steps in a flight may not preferably be more than 12. That means maximum you can provide 12 steps in a flight. Headroom. So, the clear distance between the trade and the soffit of the flight immediately above it. That should not be less than 2.2 meter. The width of the landing is equal to width of the stair. Okay. And the pitch of the staircase should not be more than 38 degrees. So obviously, if you follow the rules of rise and trade, automatically you will get the pitch of the stair less than 38 degrees. So all these are the points related to functional design. Let's see different types of staircase. Now these types are based on shape. So the first one is a straight stair. Now in this the photograph, okay, which I am highlighting here, in this straight stair is shown here. So in straight stair, if number of risers are more than 12, then obviously you need to provide landing in the direction of the flight. Okay. Normally such type of stairs will observe in the showrooms or in old structures, the Wada type of structures. In that you will find the straight staircases are provided. Then second one is quarter turn stair. Okay. Normally in the row houses, such type of quarter turn staircases are provided. Okay. That means the first flight is moving up to the mid landing and the second flight is perpendicular to it. Okay, and that is the quarter turn staircase. Then dog leg staircase. This is a very common staircase. Okay, here you can see the photograph. Okay, extreme left side is the photograph of dog leg staircase. In dog leg staircase, first flight and immediately if this is my the first flight. Okay, so this is your second flight. Okay, and this is landing at this level. So this is called as dog leg staircase. Now bifurcated stair. Bifurcated stair means normally such type of staircases are provided in public building. In that the first flight is having more width, okay, and it is extended up to some mid height, and above that it is bifurcated into two flights. Okay, the width of these two flights is less than the earlier one. Okay, this is called as bifurcated staircase. Then open well or open navel. Open well or open navel, in that opening is kept at the center and the staircase rotates around that opening. So we may provide 3 flights or we may provide 4 flights in open well staircase. Open well staircase is always known for its well ventilated nature. Geometrical stair. So in this photograph you can see geometrical stair is having the curvature. Okay. So depends on radius of curvature, different shapes are possible here. And the spiral staircase, that means a central pole is provided and the staircase just rotates around the central pole. Okay. Normally spiral staircases are provided as a emergency exits. Then for water tanks you will find spiral staircases are provided. Freestanding staircase. So it is the freestanding staircase is the type of staircase in which the landing is not having any support. That means the first flight and the second flight both are cantilevers. Okay, and both the flights at the end they support landing. But that landing does not have any support, so it is called as freestanding staircase. Okay, so these are the different types of staircases. All are based on the shape. Well, but whatever be the shape, from design point of view, there are only two types. So which are the two types? So these are the two types. The first one is horizontally spanning or transversely spanning staircase, and the second one is longitudinally spanning staircase. So what are the earlier types we saw based on shape? Okay, all are can be divided into these two types. Now the first one, horizontally spanning staircase. So in that you will find, now here a horizontal step is provided. So this is the step, okay, and it is supported on either from on both side by a wall, or on one side wall and another side beam, or on both side by beam. Okay, and that beam or wall that runs along the length of the staircase. Now in this one, span of the step is from center of this support to center of this support, that is considered as span. Okay, well, and main reinforcement is provided at bottom. Well, this the beam which run along the flight is called as stinger beam. Sometimes we may provide only single beam, and that is exactly at the center. Okay, this is the second diagram. So here the beam that runs along the length of the flight, okay, and a single beam is provided exactly at the center, okay, and the step. So on both sides, the step is provided in the form of cantilever slab. Okay, see this cantilever. Okay, on both sides cantilever is provided. Okay, well, so as it is cantilever, so tension is at top, so main steel is provided at the top face or near the top face. Okay, so this is horizontally spanned staircase. So in that span is measured horizontally. Okay. The second one is longitudinally span. Now in that the beams are provided parallel to the steps or parallel to the risers. Okay. See, this is the diagram in which the first beam is provided. Okay. So if I consider up from this side, okay, so this is the first beam which is provided here on this side, and the second beam is provided at the end of the landing. Okay. Well, so this staircase, the flight is designed as one-way slab, and this one-way slab spans across these two beams. That means the load is transferred to these two beams. Okay, that means this is longitudinally spanned staircase. Now it is also possible that the location of the beam may be different. Okay, for example, we may provide beam somewhere here. Okay, that means in that case, storage. Take one pencil. So in that case, this distance is the span. Okay. In earlier case, this was the distance. Okay, as the span. Now, sometimes the beam is provided below the first riser or below the last riser. Okay, so beam to beam, that distance is considered as span. In the next slide, we will see that. Okay, how to consider span. But the type is considered as longitudinal span staircase. Okay. Now, the effective span of the stair. How to consider the effective span of the stair? So for that, this diagram, in the diagram it is clearly mentioned that the effective span, center of this beam to center of this beam. Now this is the horizontally spanned staircase, that is considered as effective span. Okay. And in case of longitudinal span staircase, we have to refer clause number 33.1 of IS 456-2000. Okay. Well, now in that, this is the first case, okay, simplest, in which the beams are provided at the end of the landings. Okay, so the distance from center of first beam to the center of second beam is considered as effective span. Now you will observe that which part is considered here. So center of this beam, that BS by 2, okay, plus landing, width of the landing, plus going portion, plus again width of the second landing, and plus again half the width of the beam. That is total effective span. Okay, this effective span is considered horizontally. Okay, not along the length of the flight. It is the horizontal span which is considered here. Okay, it's the important point. Now, if the location of the beam is different, okay, so at the end of the going, the beams are provided. Okay, not at the end of the landing. The location of the beams are at the end of the going part. That means below the first riser and below the last riser of that flight. Okay, so in that case, the effective span is considered as center of this beam to center of this beam. So landing part is not considered. Okay, half the width of this beam plus going portion plus half the width of this beam. Again, horizontal distance is considered here. Okay. Now third case. Third case is a little bit complicated. Okay. In this case, if the beams are not available at the end of the landing or at the end of the flight, then what to do? Okay, so this is the diagram. Here it is shown that the beams are available, okay, but not along this nor not parallel to the riser. These are perpendicular to the riser. Okay, now how to design this type of staircase? Since the flight is not transferring load directly to the beam, okay, so then we have to consider that this flight, okay, both the flights will transfer load to the slab on both the side. Okay, this slab can be designed as one way or two way slab. Okay, so if you consider this as a one way slab, since the beams are available on opposite side, okay, let me show the direction of this one way slab. Now this is the reinforcement direction of this one way slab. Okay, well, now this is the beam and this is the beam. Okay, so this flight will transfer load to these two beams. Okay, and for that transfer load you have to design these two slabs. Fine. Question is, how will you consider effective span? So for that, in IS code, the equation is given as effective span is equal to G plus G is going portion. Okay, going portion means exact width of this flight, that is what is going portion, plus X plus Y. Okay, so in the diagram we will find that the slab is divided into two parts. Okay, and each part is equal, and that is XX on left side and YY on right side. Okay, well, now if X is less than or equal to 1 meter, okay, that means if that X is greater than 2 meter, okay, we have to consider 1 meter. Okay, if it is suppose 2.5, then instead of 1.25 you have to consider X is equal to 1 meter. Similar cases for Y meter also. Okay, that means at least you have to consider 1 meter on both sides, as the you have to add 1 meter on both sides. Okay, as a X and Y in addition to the going portion, and that is your effective span. Okay. Well, now what about loads? So dead load of the load can be considered as self weight of the base slab, which is given here, and self weight of the steps and floor finish. Okay, but how will you consider live load? So for live load you have to consider IS 875 part 2. Okay, so in that, for residential buildings where there is no possibility of overcrowding, the live load will be taken as 3 kN per meter square. Okay, if you remember, for normal residential structure, for designing slab, this value is 2 kN per meter square. Okay, but it is increased by 1 kN per meter square for staircase. Okay. For educational or institutional or office, assembly or industrial, mercantile, storage buildings liable to be overcrowded, the live load will be taken as 4 kN per meter square. Okay. Well, whereas the staircase is subjected to loads greater than for crowds such as wheeled vehicles, trolleys, the live load will be taken as 5 kN per meter square. Okay, so normally for public buildings, live load is to be considered as 4 kN per meter square. Okay, and if it is designed for wheeled vehicles or trolleys, then you have to design it for 5 kN per meter square. Okay, in the residential structure here it is given that if overcrowding is not there, you consider 3, and if overcrowding is there, okay, then you have to consider 4 kN per meter square. Okay, so this is important for staircase. So in case of staircase, higher live load is considered, okay, as compared to a regular slab load. Then dead load. So in dead load, self weight of the base slab you have to consider. Okay, whatever this thickness, okay, that thickness is multiplied by 25, that gives you self weight. Okay, well, now this self weight of the base slab is along the inclined portion. You have to multiply it by sec phi. Okay, how to calculate sec phi? So sec phi is equal to under root of r square plus t square divided by t. Okay, what is this? R means rise, t means strain. Okay, that means we are converting load on inclined portion to the load on horizontal portion. Fine, that's why sec phi is to be considered. Then self-height of the steps. Okay, simple. It's a triangular step, so we consider R is the rise, so R by 2 into 25. Okay, that is your self-height of the step. And floor finish. Normally, floor finish varies from 0.5 to 1 kilonewton per meter square. Okay, as a floor finish according to the finish given to the staircase. Now, live load and dead load multiplied by factor of safety 1.5, that gives you ultimate load. Okay, acting on the staircase. Well, one more clause is given in IS code regarding open well staircase. So if open well staircase is there, then obviously the landing portion, now this landing portion is common for both the flights. Okay, for example, if you are designing this flight, okay, and if you are designing this flight, okay, that means this landing portion is common for both the flights. Okay. So in that case, IS code is considering that consider W by 2 load for the landing for first flight as well as W by 2 for the second flight. Okay, so repetition of the load can be avoided. Okay, so this is applicable for landing since landing is common. Okay, so W by 2 for both the landings, automatically total load is equal. Well, now how to design a staircase. Already we saw design of slab. Okay, design of staircase is almost same. Okay, some of the points which will vary. Okay, we'll discuss here. The depth is to be fixed from deflection criteria. So L by D ratio we consider. Okay, so according to L by D ratio, you have to decide depth of the base slab. Then calculate maximum bending moment. Okay, so you just consider what are the boundary conditions are there. Okay, so the beams are either at the end of the riser or at the end of the landing. Okay, so draw the loading diagram. Okay, find the reactions. After the reactions, find the point of zero shear force. Okay, and calculate the bending moment, which is maximum at the point of zero shear force. Okay, that is the maximum bending moment. Also calculate maximum shear force. Okay, and then it's just like slab you have to design. Like check for depth. When you know maximum bending moment, okay, then you check your depth whether it is safe or not. Okay, normally when you calculate depth by L by D ratio, it is safe by bending moment criteria. Okay, the second thing is calculate area of steel, AST. So same equation we have to use in case of slab which we use. Okay, then next thing is distribution steel. So 0.12% if you use HYSD bar, that distribution steel. Okay, and perpendicular direction to the main steel you have to provide distribution steel. Okay, well, then check for deflection and check for shear. Okay, so just like one way slab you have to design a staircase. Okay, only different part is the bending moment calculation, which is the initial part. Then development length is to be provided. Okay, at both the points. Okay, which points we will see that in the reinforcement detailing portion. Now, very important part here. Look towards this diagram. In that, two first and second diagram is shown here. Okay, in the first diagram, what we can see, this is the landing portion and this is the going portion. Okay, so the bar which is at bottom in the landing is continued at bottom. Sorry, the bar which is at bottom in case of going is continued into landing at bottom. Okay, and the bar which is top is continued at top. Is it correct? No, this is not correct. Okay, this is the wrong. Okay, why it is wrong? Okay, because when this going portion is subjected to load, okay, so what will happen? This will deflect. Okay, so this bar will try to become straight, and this bar will try to become straight. Okay, so concrete cover which is quite less. Okay, this will get spalled off. Okay, and once there is a spalling of concrete cover, okay, then obviously the load carrying capacity of that flight will decrease drastically. Okay, well, now how to avoid the spalling of this concrete? Okay, so simply the bar which is at bottom, that continue at the top. Okay, and the bottom bar of the landing is continued at the top. Okay, so this is called as scissor connection. Okay, this is called as scissor connection. So this scissor connection ensures, okay, proper cover also, okay, and avoids spalling of concrete. Okay, well, now the bar which is at bottom of the landing is continued into the flight for distance LD. Okay, and that distance LD is to be measured from this point of scissor connection. Okay, the crossing point. Okay, so this is from this is the LD connection is shown here. Okay, well, so this is development length criteria. Okay, and scissor connection is very, very important. But always remember, this scissor connection is to be provided at the end of the flight, not at the starting of the flight, because at the two locations are there where there is a crank, okay, in the flight. Okay, well, first this is first landing, then this is the flight going portion. Okay, so here do not provide any scissor connection. Okay, but next portion when it is like this, okay, here you need to provide scissor connection. Okay, so at first junction of landing to the flight, it is not necessary to provide scissor connection. In fact, do not provide scissor connection. Okay, but at the second junction, okay, in between going and the landing, you have to provide scissor connection. Okay, that we'll see in the reinforcement detailing. Okay. So this is a diagram of dogleg staircase. Okay, so in this dogleg staircase, beams are provided at the end of the landing. Okay, beams are provided at the end of the landing. Now see, the bar, red color bar, which is provided at the bottom is continued into the going portion at bottom. Okay, and it is continued at top. See, this is first joint of landing with going, and this is second joint of going with landing. Okay, so at the second point, okay, it is necessary to provide scissor connection. See, the red bar is extended at the top, okay, and this is the blue bar, okay, which is extended, which is at bottom in the landing, but it is extended at top into the going portion. Okay, well, this is important. These white colored dots are nothing but distribution steel. Okay, so the main steel is provided in the form of numbers. Either you provide numbers or you say spacing. Okay, so here it is written has 9 numbers. Okay, that means this red color are 9 numbers. Okay, and these blue color bars, okay, these are also shown here. Okay, has 9 numbers. Okay, so equal bars are provided. Okay, at top and at bottom also, and the white color dots are distribution steel. Okay, so it is written here has about 211 center distribution reinforcement. Okay, then the bars which are at the end, these are also extended into the beam for development length. Okay, so here development length is shown. Okay, here also development length is shown here. Okay, well, the bars which are to be extended above the beam portion, okay, above this line. So above this line, we have to extend these bars for development length. Okay, well, so this is important because here also there is some bending moment. Okay, though we consider staircase always as simply supported, but still there is always some fixity at the end. Okay, and that's why you need to extend the bars for development length. Okay, so the bars are extended for development length. Okay, this is one type of staircase, that is dogleg staircase. Okay, this is the second type of staircase. It is called as open well staircase. Okay, so in open well staircase, same again, the landing, no scissor connection is provided here, and here scissor connection is provided. Okay, now from this landing to this landing, in between there are some steps. You can see here. Okay, so this is the second flight. Okay, so in second flight, 1, 2, 3, 4, 4 risers are provided. Okay, so here this landing, this and this landing is common. This and this landing is common. Okay, so this is the second flight, and this is third flight. Okay, so whatever main steel we can see here, that is appears as a dot here. Okay, and whatever the line is here, that appears as a dot here. Right, so obviously here distribution steel is not required because the main steel of this flight acts as distribution steel for this flight. Okay, and vice versa. Okay, well, so this is the detailing of open well staircase. So in that you have to show 3 different flights. Now another type, yeah, this is not a type, this is the details of crank beam. Okay, normally what happens in open well staircase, we cannot provide a beam at each landing level because there are 4 different landings, or if there are 3 landings, then all 3 are at 3 different levels. Okay, so at each level you cannot provide beam. Okay, so here one beam is provided, but that beam must support 2 landings which are at 2 different levels. Okay, so here this beam is provided with some inclined portion. Okay, well, so in the first portion, the landing of the first flight is at the soffit of this beam. Okay, and then in the second portion, the landing of the third flight is at the top of this beam. Okay, that means automatically this beam supports 2 different landings at 2 different level. Okay, and you don't have to increase depth considerably because to match the levels. Okay, you can have the little bit inclination to that beam, and that is called as crank beam. Okay, so just to show the provision of crank beam, okay, I had given this reinforcement detailing. Okay, then yeah, this is one more staircase in which the landing is provided in the form of cantilever. Okay, so here its cantilever is provided. It's huge cantilever in fact. Okay, well, so the beams are provided here. These beams. So here in this case, the first beam is the first beam is provided at the end of landing. The second beam, which is at mid landing, is provided, okay, at the end of the last riser. Okay, last riser of first flight, and the remaining portion is cantilever. Okay, well, so this is the detailing of the cantilever portion. Okay, so the additional bars are provided at top since there is a tension in the top portion. Yeah, this is again the simple type. Okay, normally this type of staircase is provided for the entrance. Yeah, and this is the type of the staircase. Okay, this is called as folded type of staircase. Though the design is different from folded type of staircase. Okay, so this staircase is also called as the slabless staircase. So there is no base slab. Okay, so only you will find the steps. Okay, in the side profile. Okay, so this is called as folded staircase. I mean, folded staircase, the reinforcement detailing is totally different. Okay, you will not find continuous bar. Okay, just like in dogleg staircase or open well staircase, we saw at the bottom continuous bars are provided. Okay, now here you cannot provide continuous bars. Okay, see, continuous rings are provided. So these are the detailing of the rings. Okay, so red color ring, the blue color ring. So blue color ring is the ring which starts from the beam. Okay, and then in each step, okay, it's a step which is made up of L shape, that is for red and rise. Okay, in that a ring is provided. Okay, so through the rings which are connected, okay, the load is transferred, okay, from flight to the adjoining beams. Okay, well, so this is folded type of staircase. Folded type of staircase looks elegant, very sleek because the thickness is very less. Okay, but it calls more reinforcement. Okay, more reinforcement is required at the skill work. Okay, because you need to maintain your thickness. So it's very skill work since thickness is very less. So good concrete quality is necessary in case of folded type of staircase. Okay, well, so that's it for today. This is the design of staircase. Okay, in the next lecture we'll try to solve one complete full length problem. Okay, so that you will understand it again. Okay, how to design a staircase. Thanks.